Tiga, dua, satu. Ya, oke Mas.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat
Waalaikumsalam.
siang Bapak dan Ibu sekalian. Selamat datang di webinar Tiara Vibrasindo Pratama. Terima kasih sudah meluangkan waktu dan waktunya untuk bergabung bersama kami ya hari ini. Nah, sebelumnya perkenalkan saya Adi Sukmawijaya selaku eh, Sales Teknologi Manager. Pada siang hari ini saya akan menjadi moderator dan mendampingi jalannya webinar. Nah, tema pada siang hari ini sangat menarik ya terkait dengan smart oil monitoring, easy integration dan multiple output. Jadi tentu saja ini masih related dengan lubrikasi yang mana pelumasan ataupun lubrikasi merupakan salah satu faktor yang paling krusial ya dalam menjaga keandalan dari suatu peralatan. Nah, banyaknya kegagalan equipment yang berawal dari degradasi oil itu dan tidak terdeteksi secara dini bisa dikatakan cukup banyak ya. Dengan ekspektasi smart oil monitoring ini dapat mendeteksi kontaminasi lebih awal atau menghindari unplanned downtime, mengoptimalkan interval penggantian oil maupun mendukung strategi predictive maintenance. Jadi bukan hanya monitoring ya, tetapi bagaimana kita meningkatkan kehandalan dan efisiensi dari operasional dari suatu peralatan atau equipment. Nah, bersama siang hari ini kami selaku distributor dari Atten 2 atau Atten 2 ya, yang lokasinya di Spanyol, menawarkan solusi monitoring oil ya secara online dan real time. Di sini sudah ada Guillermo Miro. Hai Guillermo.
Assalamualaikum. Good
Waalaikumsalam.
afternoon. Mhm.
Good afternoon. Yeah. Thank you for joining us today in your early time. Yeah, we have a 6 hour time difference. Yeah, as I know.
Mhm.
Yeah.
No
Okay.
problem.
And
Thank you very much.
okay, I will introduce you
Mhm.
first, and then you can continue. Yeah.
Okay.
So Guillermo is as a CTO ya, Chief Technology Officer, and has extensive oil condition monitoring and smart sensor technology experience ya. And then today he will share with us how smart oil monitoring can be easily integrated into your system and how multiple output provide flexibility for industrial application.
Mhm.
Sorry, I miss one thing. I will use Indonesian ya. So,
No problem.
Bapak dan Ibu, pada hari ini di webinar ini kita menyiapkan hadiah juga ya berupa 4 e-wallet untuk peserta yang beruntung ya. Jadi 4 e-wallet ini dua untuk yang aktif selama sesi Q&A dan yang kedua gift card atau e-wallet nanti untuk dua peserta yang mengisi feedback survei. Nah, jadi kami mengendorse untuk Bapak dan Ibu untuk eh, mengisi di kolom chat ya atau kolom Q&A apabila ingin bertanya dan silakan selama proses materi berlangsung bisa langsung Q&A. Nah, and then so please welcome Mr. Guillermo. The floor is yours.
Thank
Please
you very
continue.
much. I will share my screen. So, okay, perfect. Is my screen visible so we can see it?
Yeah,
Okay.
it's visible.
So yeah, thank you very much to Tiara for getting that webinar ready and all the attendees. I mean, I appreciate your time and your effort in coming here. Okay, so basically we are going to talk about one of our new products. Okay, that is the smart monitoring kit. Um, and with the focus on the easy integration and different outputs that it has. Okay, but basically we will explain what is the technology inside, what is the product, and then some business cases on top of them. Okay, so first a brief introduction about myself. As Adi has explained, I am Guillermo Miró. I'm the CTO of Atten. I'm mechanical engineer. I studied my mechanical engineer in Spain, and then I did my PhD in lubrication systems in diesel engines, and I learned a lot about sensors there. And since 2017, so 9 years ago, I started at Atten as a technical part of the technical team, where I was responsible for installation, technical support, and R&D. And recently, I was appointed to CTO. So basically, my role is basically a technical role supporting my colleagues and our customers in getting as much out of the sensors as they can. And then our company, so we are Atten Deep Monitoring Solutions. We are a company that is developing, and we are the owners of this state-of-the-art optical technology, okay, and we use it for lubricants. We measure the lubricant and asset condition to ensure to extract useful information for the customer to take decisions on their asset. We implement algorithms, and we use digital communications to extract the data and to deliver it to the customer. This is a technology that it's almost 25 years old. Okay, the first development started 25 years old, and this led to all these protection IP and products. We are based in Spain, Western Europe, in the north of Spain. This is a region called Basque Country, and we have offices in Chile, in South America either. And then we have a very broad network of partners, where in Indonesia, Tiara is our partner, and we are supporting main markets all over the world. So South America, North America, and Central America, Europe, and then Asia, APAC region with Australia, all Southeast Asia, and then China, Japan, South Korea, etc. Then our technology.
Particle contamination in oil lubrication systems is one of the major causes of wear and failures in critical machinery. For over 10 years, Atten has been providing technical support to the industrial sector enabling them to make precise decisions thanks to their advanced and patented optical technology. By expanding the information on asset health and lubricant quality, problems can be detected or avoided early. As a pioneer in their industry, Atten launched their first sensor on the market over 10 years ago and has since developed 7 solutions with 36 associated patents. Their unique technology applies advanced image analysis and artificial intelligence techniques, allowing them to count particles and provide standardized information, ISO 4406, with exclusive features such as bubble discrimination, particle shape analysis, and fluid degradation. With thousands of sensors installed in over 20 countries, Atten has adapted its team of engineers to provide the best possible support according to each customer's needs. If you want to take control of your assets, contact the Atten team.
Okay, so yeah, basically what we did is we develop technologies focused on monitoring these 4 main aspects, okay? One is lubricant condition, where we measure oil condition using our own parameter. Then we have a viscometer that can be integrated, okay? Then we have particle counting or contamination monitoring using ISO 4406 standard or NAS 1638 standard. We are able to, inside of this contamination, measure the morphology and the shape of the particles to detect additional information about the wear processes that are occurring in the machine, adding a new layer of information, a new output of information from the monitoring. And then we are able to measure also water presence, okay? Water presence using a near infrared sensor and providing ppm level results. So, sorry, the first device, it's oilware. We saw the video before, but let's do it again. This is one of the products that is inside of the SMK, okay, and this is called oilware, okay. Oilware, it's a contamination monitor, okay, and sensor that detects particles and bubbles larger than 4 microns, and it's designed to work online with no human intervention, okay, and it provides real-time information on the asset condition. Okay, so how this it works is it's an inline microscope, okay, so what it does, it has illumination on one side, optics and camera on the other side, and the oil is flowing in the middle. So based on that, we take relevant pictures of the system, of the fluid, and we quantify the particles per sizes, getting cleanliness codes, bubble counts. We are able to distinguish between bubbles and particles, and we are able to distinguish morphologies for particles above a certain limit. And then we provide also oil condition and images. Okay, this is a summary of what we do. So basically we provide ISO contamination. Okay, this can be also NAS. Okay, in case your scenario is NAS based. Okay, but we provide this. Then we provide images that provides we provide bubble discrimination. So the sensor is automatically discriminating between particles and bubbles, thus providing a result within a wider range of operations, because when there are bubbles, counting particles becomes more difficult, but we are able to overcome that. Then we provide root cause analysis as said, and then we provide oil condition parameter based on the visual aspect of the lubricant. Okay, and then we also provide images. This is the fifth part, no? So we provide all of this information. This is an example of how the amount of information we can extract. This is a gearbox failure, and it was like videoed. So we see all the particles passing through the system, different sizes, quantities, shapes. We even saw a bubble passing through. So, and even the aspect of the lubricant. So all of this is gathering information. It's increasing the awareness of the asset health, and provides a different source of information for taking for making decisions on our asset condition. Okay, just as a reference, this is a 300 micron circle. So some of these particles are above 200 micron or even 300 micron. So it's a very bad condition for this gearbox, just as a reference. Then the other device that is included in this SMK that we are presenting today is the oil health. Okay, so let's.
Do you change the oil in your equipment too frequently? Or are you delaying the change and putting the performance of the equipment and safety at risk? Atten2's Oil Health Solutions help you make optimal decisions, preventing wasted resources and costly breakdowns. Our optical spectrometry technology analyzes the lubricant using visible light, revealing crucial information about its lifespan. It employs infrared spectrometry to accurately measure water content, providing data in ppm with a high correlation to Carl Fisher tests. It also measures the fluid's temperature. To make better decisions, more information is key. Changes in a lubricant's lifespan can be the result of various factors, such as natural degradation, external contamination, or human error. That's why our online, real-time technology provides you with precise information, allowing you to make informed decisions in any situation. Monitoring trends over time allows you to identify significant changes in lubricant performance and take preventive measures before major issues arise. With our new software, you can set your own limits, extending the life of the lubricant and better protect your equipment. Keep your assets in top condition with Atten2's Oil Health Solutions.
So this is the second product we were commenting. This is a visual near-infrared spectrometer. So all principles are optical, and we are willing to monitor both oil condition, okay, and then water presence at a molecular level. So oil condition, it's a process, or let's say better, oil degradation is a process that happens in lubricants due to the contact with air and temperature, and it finally ends in the oil change because additive depletion, viscosity increase, risk of varnish and sludge. So what we provide is a tool that supports you in this degradation or in this oil condition change journey, okay? By measuring the visual aspect of the lubricant and the near-infrared aspect of the lubricant, we are able to trend the oil condition over time. And we are successfully have correlated that with some of these lab parameters, okay? So we use ruler, oxidation, acid number, and viscosity to decide an index, okay? So we provide a 0% fresh oil index and 100% used oil index. And based on that, the additional decisions can be made on oil change, on oil condition changes, okay? And then regarding the oil moisture, what we did is this near-infrared spectrometer where we measure the molecules of water, okay? Based on the near-infrared spectra, we excite the molecules of water with this specific wavelength, and the more water presence, the less signal we receive. So we are able to correlate that with water presence. Okay, so it will be like when we have a blue ball, if we illuminate it with all colors, only returns blue, all the other colors are absorbed. So in this case will be the same. We emit a light that it's only absorbed by the molecules of water, and then we receive less light. This is an absorbance spectrometer. No? So the less signal we receive, the more accurate, the more amount of water we have, and this is able to measure ppms of water. The main advantage of this technology is that we can measure any type of water. Okay, people who is aware of water presence in lubricant, it can be in 3 states: dissolved, emulsified, and free water. So we are able to monitor every type of water and above saturation level. So we can measure higher than 2, 5, 10% water levels with confidence with this device. Now, jumping to the product that we are going to talk today. So this is called a Smart Monitoring Kit. Okay, and this is an integration of sensors plus other type of outputs. Okay, as the motto of the training was multiple outputs, this device is designed for that. We have a device that it's able to measure the oil properly within a simple way. Okay, by just connecting two hoses, we are able to measure the oil with confidence. We can, because it can have a pump or it cannot have a pump, and then we have multiple outputs. We have the HMI, we have USB stick that can store the data, and then we have Modbus TCP and digital outputs to extract the data and to extract information from the unit. Okay, so basically these are, and then we have remote communications either. So we have all these multiple outputs that we can use. So basically this device, it's basically there are 4 types. Okay, so there is SMK with a valve, SMK with a pump, and with or without display. Okay, so you can choose. If display is not needed, you can choose without a display. If display is needed, you can choose with or without a pump, and here also with or without a pump. Okay, so these are all options. And basically this device is integrating both OilWare and Oil Health Pro Max solutions. Okay, and it also provides an HMI with trends, with flow rate display. It has a flow meter inside of it. It has pump control. It has a USB port and a TCP/IP communication as commented. Okay, so which are the benefits? So basically the first benefit is that we have a plug and play solution. Okay, so it's easier to integrate than the sensors alone. Okay, with this enclosure, everything is inside of it. Then you have the 2 technologies in one unit, so it will be a simpler approach, a more complete approach than purchasing one sensor alone. With these 2 devices, we have full quality, I would say full house devices. Okay, so basically the best devices with all the parameters. And then we can add also a third parameter, that is the viscometer. Okay, we can add the viscometer from the outside, so you could have viscosity, oil condition, water presence, and contamination monitoring only in one device. And then you can have embedded display on the field. You can have remote communication. So it's a very, very advanced. In terms of communication, it's a very versatile product. And now some examples, okay, of cases. First of all, I have to say this is a new product, so we do not have a specific business case with this specific product, but we are going to share how sensors have provided information, but you can see they are being currently used on the field in some examples. Okay, this is a hydraulic unit, and this is a paper machine. Okay, so this is how we approach the market with this device. But as I said, it's a new product. It has less than a year, so there is limited information on the business cases on that. Okay, what I'm going to explain is cases that are linked to the sensors inside of it. Okay, so in this case, first of all, this is one for the mining industry. Okay, in this case, we were monitoring the primary crusher. Okay, where the primary crusher in this mine it's critical because it processes all the material that then it goes through the plant. So they were having issues with contamination and filter performance. Okay, so we were able to detect a sudden increase in a matter of days of contamination and particles, and not also that, but tailoring it to an approach of wear mode, okay, where we were having basically a sudden increase in sliding wear. Okay, based on that, we were able to detect a failure in one of the bearings of the gearbox that was moving the crusher, and they, since their machine was so critical, they were not able to wait for a sample. They were using our sensors to implement corrective actions that mitigate the issue and allowed production to continue without stopping until they were reaching the shutdown. Okay, so it was 23rd of May and they were stopping at 3rd of June. So they were needing 15 days, additional 15 days more or less of continued operation. So they did whatever they could. They did lubricant bleed and feeds. They increased the pump speed of the system to filter the oil. They were changing filters every day. And they were also, when available, let's say, reducing the power of the machine, no? Reducing the output of the machine to reduce the mechanical stress on the system. Okay, so based on that, they were able to maintain the machine operating, replace the bearing when there was the shutdown, and when they started again, system went back to normal with very similar values as of before the damage. No, so in this case they saved 15 days of production and around $1 million in production. Okay. Then another application, nice application, it's tire manufacturers, okay, where we have different, tire manufacturing is a very complex process. So we have been monitoring compressors, gearboxes in different places. We have monitored hydraulic systems. In this case, this is a study from a major manufacturer where they were deciding which approach way they were using to monitor the calendar gearbox. Okay, so they experienced as a failure in the lower gearbox due to a bearing failure, and then this is a mess because this is a um, very dependent line. So if the calendar fails, all the rest stops. So they were doing their critically analysis, and one of the key points was that the detectability of the gearbox failure in a range out of 5, it was 4. No, so they decided to install sensors, and they reduced the gearbox failure. And in fact, recently we detected in a gearbox a contamination with the powder of the tire. There is a powder that they use to separate the tire sheets, the let's say the rubber sheets, and we detected an abnormal contamination with the sensors, and they were able to replace the oil in time to reduce the influence of this powder on the system. But because they are using sensors, they reduce the criticality. Okay. And then in the same plant, we monitored the 6-screw compressors because they consider it critical. And basically, the business case there was the replacement of the lubricant, the oil change intervals increase. In this case, they were having a 6-month fixed oil change. Okay, and the oil was costing around 20 euros a liter, so it will be 5 or 6 times a common price for lubricants for your reference. So based on this scenario, they decided to implement sensors to try to extend oil life, okay, but monitoring continuously. So basically what they did is they were able to increase oil change from 6 months to 2 years, and with all the lubricant changes and the compressors that they were around 20,000 euros in savings, okay, around $20,000 in savings, and the sensors were paid in less than a year. And then for sure, sensors were also providing asset health, but in this case, only the oil change was 25,000 euros. And since they change the oil once every 2 years, it's 3,000 euros. So they for 10 years they reduced. So they earned 200,000 euros around it. No, just by basically implementing a condition-based oil change with sensors. Then we have another examples for paper plants, okay, where we were monitoring pulpers and Yankees dryers gearboxes. Okay, so this is I would say a a simplified version of the SMK3 that we showed before, where we have oil wear and moisture inside of a box. And in this case, they have a gearbox with a pump to filter the oil. So we just use this main filter. We will talk about that later. So we were able to monitor, in this case, pulpers. We were monitoring lubrication, so wet and dry lubrication systems, and then Yankees of the main machines. We implemented eight sensors in each, and then we use our cloud to gather the data. And we were able to see multiple. I do not want to get into detail a lot, but we were able to detect a lot of water events. Okay, basically every time they clean the machines, water is used continuously in the paper plants. So every time they use water, a water contamination was shown. So every time the customer received this notification was informed. But especially in pulpers, the main issue is that the water can fall down from the tank, and it rains on the gearbox, and if the seals are not properly in proper condition, the water goes in through the pulper system. So we detected also this, and so we saw the pulper water contamination, and we saw even the dynamics of the contamination. So every time they started and stopped the pulper, additional water was coming in, so it was curious. And then we saw also in a Yankee dryer, in the Yankee gearbox, we saw that moisture present, so it climbed for 2000 to 17,000, and then it was dehydrated. Okay, so it's interesting, no, especially for water content, to use this type of technology. So what types of applications we are currently monitoring? As explained, we are monitoring in the mining sectors different parts of the system, both on the static equipment and on the off-road equipment. So we have crushers, gearboxes in belts, hydraulic systems and brake systems in excavators, lubrication systems in wet mills and dry mills, drills, truck shovels, you name it. Okay, there are different systems that you can measure. Unfortunately, no engine monitoring, no diesel engine monitoring, but for the rest of the lubricated systems in a mining, we are fine. In the pulp and paper sector, I said every type of asset in the system that is lubricated. So we start from the pulper gearboxes, then we can measure the shoe press hydraulic contamination, the refining process, the Yankee dryers, and then if you have auxiliary hydraulic pumps or compressors are also part of that. Then in automotive, where we have a lot of experience either, so compressors, presses, painting systems, cleaning systems, in case you have cleaning, you clean parts, robots, gearboxes, main gearboxes processes. We have end-on-line gearboxes for some automotive manufacturers. And also, we can monitor, as said, no, in your process, if it's tire or an automotive part, with calendars, bamburis, etc. And then in energy sector, we are successfully monitoring assets in both renewable and non-renewable energies or conventional energies, such as gas and steam turbines. Okay, different sizes, different approaches. Wind turbine gearboxes, main pumps or hydraulic pitch lubrication systems, and also generators in steam turbines and launching systems, no, like the starting system of the turbines. And then in, let's say, petrochemical sector or types of process sectors, pumps, agitators and mixers, centrifuges, gas turbines, steam turbines, mills, extruders, any place that is a lubricated system that is critical, we can monitor. Okay, so it's up to every process, but we have experiences in a lot of industries, so we can support with our engineering on top of that. Okay, so then the last part, regarding how to integrate and to extract all the outputs. Okay, we have this kind of pathway, okay, to support that. So basically, we need to do, in terms of technical, we need to do a technical validation of the application, okay? For example, as we said, diesel engines, because of soot, gas engines, they require a specific product, okay? So not every installation will be straightforward, so it needs to, our partners at Tiara knows which applications are easier and which one are not possible. Then we do some, together with the customer, Tiara and us, we do pre-engineering, like deciding the mechanical installation, deciding the hydraulics, deciding the communications, and then we commission the system and provide some support in terms of data, no? How to integrate it, how to analyze the data, and so. So when deciding how to install a sensor or an SMK or whatever device, it's interesting to focus in these 4 axes, okay? So one is physical integration, where we are going to get the sensor, place it on the machine, fix it so it doesn't fall down, vibrations, etc. Then we have the hydraulic part. So where do we get the oil out from the machine? Where do we return the oil? Is the oil representative of the machine? Then we have where to get power supplies and comms integration. Okay, how do we connect the system to the power and to the rest of the plant communications? And then the last but maybe most overview part, it's how we are going to take advantage of the data, how we extract value from the data. No, this part should be also involved in the conversation. Okay, so where do we recommend to install sensors? Okay, so it's like when we take a sample. Sorry, it's like when we take a sample from our body, no? So from the blood, no? This is this example of blood test and lubricant oil condition monitoring. It's a similar approach. So we need to decide where to take the information to be useful, no? So, for example, if we take a sample from our blood after the kidney, we won't see no relevant information because most of the toxins and the products that are harmful to us are being kept in the kidney and then they are just extracted via urine, no? So in this case, depending on what we want, normally what we would like to have is information from the asset wear processes, no? Or for the asset contamination sources. So it will be typically after critical elements, bearing, gas, hydraulic systems, before the tank. Or if we are not able to do that, in auxiliary conditioning circuits such as a filtration system, a cooling system, but always before the filters, because if not, we will be monitoring filter efficiency. Then if you have a sampling point for laboratory analysis, for sure this is a good point to start. And then we always recommend to use existing points in the system. Okay, if you see a tap, a cap of a hole or whatever, or even a temperature sensor that can be moved, or a pressure sensor that can be, let's say, we can implement a fitting that maintains the pressure sensor but also adds a hose port. This could be available, and then you can always check relevant standards to provide condition monitoring ports to your system. What type of information, what type of installation information do we need? So we need 24 volts VDC, okay, power supply. We need maximum 1 amp for the pump system, okay. You can find this on the datasheet, okay. It's on the datasheet, and then we provide typically cables to the applications, okay? So you can purchase from Tiara the appropriate cables. It's M12, so it's a standard instrumentation cable, but you can order from us, okay? And then the main communication type is Modbus TCP, but then you have all these additional communications options that are you can provide remote communication to it, so you can send the data to another place via cellular connectivity, digital output that can be used, HMI, and also USB stick. Okay, so all these additional communications options are available for the SMK3. In terms of hydraulics, we need a low flow bypass, okay? So recommended 200 milliliters a minute, okay? And then depending on the pressure of the system, we need to divide it between non-pressurized system and pressurized systems, okay? So in case we are in a non-pressurized system, we use the pump version, and the pressure allowed is between 0 and 2.5 bar. And then if we are in a pressurized system, we have the valve version, okay, the non-pump version that can have between 2 and 16 bars, okay, and the sensor port or the device port dimension is 1/8 of a gas inch. We do not have viscosity limitations normally, but if you are using a pump system, the hotter the oil and the lower the viscosity the oil, it's better, okay? But system can provide a result even for high viscosity lubricants, okay? And then which types of components that can be used? So hoses, ball valves, pre-filters, check valves to avoid the oil coming back, sampling points if needed, pressure indicators, and then if you want, you can add a flow control or flow viewer device on the on the output. Pre-filters are important because they are limiting limiting the risk of having a very big particle clogging clogging the flow meter and affecting the pump. Okay, so some pre-filter is needed always. So normal recommendations. Okay, so pipe section needs to be studied for different viscosity, especially for very high viscosities. Then we need to ensure high bubble content. If it's limiting, okay, if there is bubble content, we can add additional accessories before that called bubble elimination system to reduce the influence of bubbles, okay? As I said before, we can distinguish between particles and bubbles, but up to a certain extent, okay? For some applications like bearings or gearboxes, like dynamic gearboxes, we always recommend to use a bubble elimination system that limits the presence of bubbles, allowing us to perform a better measurement, okay? And then always check for leakages when installing or when checking the result, so there is no leakage on the system, okay? And then in terms of connectivity, sensors and SMK3, it's available to do a wide variety of communications, okay? We can connect wireless to a cloud, we can connect into the network and being used as another computer in the network, or we can do a traditional integration into CMS, PLC, or SCADA systems via a PLC and a Modbus integration, okay? So this is with our devices, the on-premise software is provided, okay? This software allows us to communicate with the sensors and extract information, capture data in real time, configure the sensors for different outputs, set alarms that are visible on the software and to extract information. Okay, so this is an on-premise software that allows you to do basic things with the sensor and capture data. And then the other part is you can build a remote, we can support you in having a remote solution for your system, okay, based on a cloud. This is a video we recorded for the cloud, so we can explain all the benefits. In order to access the Atten website, cloud website, please follow the following address, iotcloud.attendo.com, and this will link us to the username and password. I'm not sure if it can be heard properly. I will talk on top of that. So basically, there is a dedicated website with a dedicated user and password, and as soon as we got in, we have access to all of our dashboards, okay? We typically generate a dashboard for every device, okay? So if you have 10 assets, you have 10 dashboards. And every dashboard has more or less the same structure, okay? Where we have the main parameter data, okay? So if we have one or two types of sensors, we have the main relevant information for each sensor. We can tailor the information with the filter, with the time filter. So we can choose quick ranges or we can choose our own. We can refresh or we can provide real time, so it will show the last result. We can just play with historic data. And then we have the last time the sensor has sent data to us. Then we have main parameters like water, oil condition, oil temperature, ISO 4406, cleanliness code. We can add any yes if needed. Okay, and then we have also the last image. Okay, images are sent on an hourly basis. Okay, but we can see the image of the sensor on the cloud solution. Okay, then we have the time series. Oh, sorry. You can also download the images in for your information. Okay, with the button you download the images to your computer. Okay, then we have the time series. Okay, so we can see longer trends with the time series, and so we have ISO 4406. We have total particles and bubbles, and then as I said, we can enlarge the images. We can see all the image. We can do zoom on the graph, and we see very detailed results. And then also we can extract every widget information. We can extract it, export data. We export either the CSV file, or we can download the image as a PNG to add to our report, to send via email, etc. Right? Then we have additional widgets: total particles and bubbles, big particles, shape recognition features, oil condition, and then in this case we have water presence and temperature. In this case, since we were monitoring with a similar, this will be an SMK3 like webinar. Then we are adding a new feature that you can set up your own alarms, and an email will be sent to you, so you can see you can receive your own alarms. Okay, if you set OD threshold, like when the system is above 80 on the OD, send me an email. So you will receive an email on top of that, and you can turn off or on the emails. And this will allow you to check how the alarms are performing in real time. Okay. So this is the dashboard approach. And then, yeah, this is additional examples. And then, so just to finish, so we are focused on providing a risk reduction in operating assets, basically online monitoring the condition of the lubricant and the wear process that are occurring in the machine, and then to increase productivity and reduce the cost of operating, and increasing maintenance ability to take actions on the system. So that's all from my side. Thank you very much for your time. And now we can have some time for questions.
Okay, thank you, Guillermo, for your very crystal clear explanation. Yeah, so we can move to Q&A, question and answer. We have a lot of question over here,
Okay.
and I looks likely need to like a grouping, yeah, for a
Okay.
similar
Perfect.
question. So first thing about the hardware, actually the sensor, yeah. So what kind of sensor we need to monitor the general oil cleanliness monitoring? And then for the sensor, are there any type of ATEX or strictly safe? And then can you explain about the sensor require recalibration, or the sensor require
Okay.
the frequency of recalibration? Okay,
Okay.
first thing
So
you can
yes,
answer.
let's do one at a time.
Yeah,
Yes.
yeah.
So the first question was how to monitor contamination on the system. So one of the devices that we discussed is oilware. Okay, this is the contamination monitor. So this one should be the one if you are willing to monitor only contamination of the system. Solid contamination is the main causes for lubricant related failures. So I understand that. So oilware will be the one to choose. Especially oilware, also linking to the second question, Oiler has also, we have an EX certified version, okay, so it's ATEX certified, zone 2, okay, and we can provide also zone 1 solutions to the market, okay. So if the customer is interested in a zone 2 or zone 1 solution, we can provide pricing for that for this solution, okay. And then the last question was life cycle of the sensors. So sensors are, I mean, when we talk about recalibration, we are more focusing on lab results, and so this is a field device. Okay, so we have the tool to provide field verifications of the unit, and then every 4 years we recommend an overhaul of the system. Okay, it's a process sensor. It's like a process sensor. It's not like a lab sensor. So we recommend a yearly cleaning in most of the applications. Okay, so this customer is responsible to clean the system with flashing solvent, and so it's a procedure in the manual. Then on the second year, we recommend a field verification. We do not dismount the sensor from the machine. We connect our own hoses, and with our own fluid, we check the performance of the sensor, and we confirm it can run for other 2 years. And in 4 years, we recommend the sensor to be dismounted and send it over to the offices um, to be checked. No, it's 4 years, needs to be checked and put up to date in firmware and so. Okay, I think I
So
answered 3 questions.
yes, so we need maybe for yearly to send the sensor to manufacturer, and
Yes,
then every year we need to have a cleaning,
yes,
solvent,
cleaning
something like
procedure,
that.
but it's done by the customer normally. And then every
Yes,
2 years, Tiara in this case can support you in doing a
so
verification, and we extend the certification, the calibration certification, we extend it for 2 years.
okay. And then you mentioned about the traditional lab, yeah. It's related with the other question, yeah. So, as a user, yeah, uh, what is the differences about regarding the quality and the accuracy, yeah, between real-time online
Mhm.
oil sensor compared with the traditional lab, yeah.
Okay, so I would say they are complementary, but they are substantially different. Okay, it's like it's like doing an ECG for your heart to detect an issue with your heart, and then having an intelligent and a smart clock and a smart watch that can measure your heart rate. So probably they are not measuring even the same parameter, but they are willing to do different things. In our case, we have a lot of studies that correlates our results with lab parameters, but we do expect always some deviations between lab parameters or lab measurements and sensor measurements, basically because we are not measuring the same thing. When we measure on the machine, the oil is not getting out of the machine. We are just taking care of what is inside of the machine, and then when you take the sample and you send it to the lab, there is a process that it's happening. So there is a difference for sure between what the lab is providing and what the sensor is providing in terms of actual values. So there is a different approach, but they correlate very well. But they are not the same value. They are not the same. They have not the same purpose either.
Yeah, it's a good analogy when we use this online oil monitoring, same like as a smartwatch, but
Mhm.
for sure we need to have a medical checkup, yeah, minimum
Yes, yes. Mhm.
yearly.
Yes, we do not. We do not. We say we are complementary. So our sensors can support you by sending samples when they are needed to be sent to gather more evidences about an issue. Okay, I just have this morning. I have a call with a customer. This is a manufacturing plant for wind turbine gearboxes. They got an increase in the water presence in their milling machine. They have a milling machine, and he said, "Oh, I saw the water increase yesterday. I'm going to send a sample to the lab to confirm. The oil looks different." Okay, this is good. This is what they needed, no? So they need quick actions and quick inputs to decide if what they need to do. Now they take a sample. If they after 4 or 5 times they will look at the oil and they say, okay, let's replace the oil, let's filter the oil. So it's a combination of actions that can be cascaded from the sensor data. No, this is what we look for.
Okay, okay. Okay, thank you. So we can continue related with the feature, yeah, the main feature, yeah. First
Okay.
thing, can this sensor detect metal, for example, ferrous, copper,
Mhm.
chromium, and non-metal? And then uh, about is there any AI, for example, can have a analysis, recommendation, or maybe uh, how many percents left for the health of the oil?
Mhm. So yeah, this is something. So the first question is we are not able to distinguish between ferrous and non-ferrous. Okay, so we only measure quantity, size, and shape of the particles, but we do not measure if it's ferrous or non-ferrous. I'm sorry for that. And then the other topic is we do not have any module inside of the sensor that provides intelligence. Okay, we have artificial intelligence to detect the shape of the particles because this is a machine learning algorithm, but we still do not have any module that, based on the historical data, provides information about the remaining useful life of the asset. But we are working on that, and this is something it's on our R&D, no? To develop the sensor to be more smart in terms of providing information to the customer on their asset.
Okay, and then percentage, how many percent left the oil health?
Yes, this is the same, no? I mean, we provide an
Yeah,
index that can be
yeah.
trend, but again, this is based on a line. I mean, if you have a sudden contamination increase or whatever issue, we
Mm.
cannot predict a sudden change in the trend, but you can predict a linear change on the trend. It's a
Okay,
very easy thing, but it's not done in the sensor. You need to do it in your own acquisition system.
okay, okay. And then I move to other question, yeah, related the participant read like a journal, yeah,
Mm-hmm.
or then explain about the optical sensor based oil monitoring technology that Atten to use is
Mm-hmm.
inferior compared to electromagnetic sensor developed by competitor. Maybe you can clarify or elaborate about this.
Yeah, maybe I need additional clarification for this question because electromagnetic sensors it's a broad approach to sensors. There are condition sensors that are electromagnetic based, and there are wear particle sensors that are also electromagnetic based. So if he can elaborate a little more about which type of sensor is he talking about electromagnetic sensors, we can elaborate on that. Yes, but
Oh,
without information, I do not want to explain a lot about. I would like to focus on this question.
understand. And then also inform about the internal electronic if
Mhm.
running on 85 degrees Celsius oil, it can broken the sensor, is it?
So sensor temperature limit is 70 degrees, okay, Celsius, but we need to consider that this is device temperature. Okay, so oil can be, especially if you take the oil from the machine out, there is some cool down from the machine to the sensor, and normally where you take the sample is not where the temperature of the oil is measured. So I would say that
Mm.
depends on the project, 85 degrees can be totally feasible because 85 degrees in the bearing means it's 80 on the return pipe, 75 on the sampling port, and 65 on the sensor because you build your own bypass and it's heating and it's like acting as a cooler before going into the system. We have also coolers, but I would say that this is a soft limit depending on the customer installation.
Okay, okay, nice. Let me check again about question on a chat room ya.
There are a lot of
If
questions.
if oilware is used on a machine that operate continuously under high oil contamination level caused by dust, vibration, and extreme
Mhm.
temperature, which accelerate wear, can it help maintain its reliability?
Definitely. I mean, our technology, it's able to measure high contamination levels above other types of sensors. So we are able to measure 23s, 24s, 25, ISO 4 reliable. So in this case, they have a lot of high contamination. We should focus more on the integration because vibrations can affect definitely, but we have rugged solutions that can not the ones that we have shown today, but we have rugged solutions that work well in in space like vibration requirements. Okay, that can measure in these scenarios. Extreme temperatures is something we need to discuss, but normally these rugged scenarios requires a specific engineering. So if they contact you, we can do some study for them on these specific rugged scenarios.
Okay, okay. So we move to portable portable
Okay.
particle counter ya, not the sensor.
Mhm.
Especially if we running into different type of oil, do we need to
Mhm.
recalibrate the portable particle counter before use
So
or
there is
before
another
testing?
product that we have that it's a suitcase, okay, that it's covering this ask. It has a battery and it has a tablet. And for monitoring particle contamination, there is no need to recalibrate the unit for every oil, okay? But for oil condition sensor, some of the suitcases has oil condition sensors. So in this case, the oil condition sensor requires that you profile the oil, okay? This is done once, and there is a database of oils, but and this every oil takes half an hour to be profiled, and as soon as this is done, you have always the oil profile linked to the asset. So if you have gearboxes, compressors, and hydraulic systems, you profile the three oils, and then every time you measure every gearbox, the oil will be there to profile. So yes, you need to profile the oil, but it's once a time profile. You don't need to do this every time.
Okay. As well as the SMK type, yeah, we do not need to
Yeah,
recalibrate.
SNK type, since it's designed to be on the asset, for the oil condition and water presence, it requires a profile. Okay, but this is done once when you install the sensor. And then if you change the oil of the machine, you need to do it again. But it's only done once at the beginning of the installation. And we can do it even in our premises, so we send it over with the correct profile to you.
Okay. Okay. And then,
Let me add something, Adi, one thing more. This is
okay, okay,
also,
sure.
it can be done by the Atten software. So there is no, you don't need our support to do that. Okay, it's on the software. So you select the oil and you just send the profile to the sensor and it's implemented. You don't need our support, but we can give our support. That's the point. Thank you.
Okay. Okay. So, another technical detail about the sensor, yeah.
Yes.
So, the maximum viscosity that the sensor can use, and then
Hmm.
type of oil, yeah, is it uh, can be used for synthetic,
Hmm.
mineral, and especially
Okay.
for polyalpha glycol, yeah, or phosphate ester oil.
Yes. So SMK3, I would say it's a much more complex device with pumps, pre-filters, flow meters. So there is a viscosity limitation on that. It's 540 centistokes, but the sensors alone, and if we provide a different type of product, they can deal with ISO BG 680s, ISO BG 460s, so very high viscosity oils, and even very low viscosity oils. Okay, so if you want to measure diesel fluid, you can also use our sensors. Okay, and on the other hand, regarding fluid compatibility, SMK3 is also limited, as said, because there are a lot of devices with different assets, but we provide solutions for every type of fluid. Polyalkylene glycols, phosphate esters fluids. We provide tailored wetted materials for the products, and we have built SMK3s with tailored materials. So if you want an SMK3 with wetted materials for phosphate esters, it can be done. Or for water glycol based fluids, it can be done.
Oh, okay, nice. And we need to inform manufacturer first, yeah, what kind of oil that the
Yes.
sensor will
If you
use,
want
yeah.
a tailored solution, we need to be informed, so we provide you with the appropriate type of product.
Yes. Okay, maybe still a lot of question, maybe one question, yeah. One question left. Last
Mhm.
question, yeah. Okay, it's related with not the sensor, yeah, but the data reliability, yeah, because in real industrial system we often
Mhm.
have a bubble or transient
Yes.
condition, yeah, during startup. From your
Uh-huh.
experience, how does the monitoring algorithm ensure the spike in ISO code or water ppm are actual degradation signal and not just temporary
Mhm.
hydraulic disturbance or anomaly? Yeah?
No, this is a good question. Seems there is a lot of experience with sensors in this question. So, yeah, I mean, this is a completely legitimate question, no? So, sensors, in our case specifically, they are measuring every piece of data they receive and they provide the result. So, normally we have transient conditions in the machine. We have a lot of bubble generated at the beginning and a lot of resuspension of wear and contamination at the starting of a system. Sometimes, no, it depends on the machine. It depends on the design of the tank. So normally, what we recommend to the customer is that they cluster the information. So they need to cluster the information when the machine is stopped, when the machine is on, if there are different operational conditions, try to cluster them either. So this is what the most powerful part of the sensors, that you can link operational conditions with sensor data to discard whatever is not useful and to take advantage of the different type of information. Let me explain an easy example here. So when you start a gearbox, you'd see a different type of wear than if you run the gearbox for a long time. So depending on the speed of the gearbox, we can separate two different completely failure phenomena. One is cold start, when you have a lot of sliding wear and cutting wear that can generate failures on the bearings because there is no lubrication, so the bearings are running dry. But if you have wear only when the machine is operating at full speed, this is a different type of wear because this is more a gear wear because the gears are old, let's call it this way, and the gear is getting damaged and you have more fatigue wear. So if you take a sample, you do not know where this wear is coming from. But if you are able to monitor in real time and distinguish between these two stages, it can give you different outputs. And regarding the startups and stops, not for every equipment, but for example, in steam turbines and gas turbines, startups are very useful types of pieces of equipment because they are always the same. So imagine if you, it's like a stress test, no? Like when you are when you are an athlete, you need to do a stress test every year to see how is your body, and you do always the same run. It's 5 minutes at 10 kilometers per hour, then whatever, and they monitor you, no? So every time you start a turbine, it's always the same process. So it's a stress test. So if you monitor every startup independently as an event, you could see if there is a trend increasing over time, no? That it's affecting your asset. And it's something you do not see when the machine is operating normally because it's not stressed in the same level as it is during a startup. So I know data reliability can be somehow tricky to explain, but if you confirm the oil is representative while you are starting or in transient conditions, the information will be also representative, so you can also extract other type of information from that. If not, you can always filter out these parts and get the piece of information that is representative of your asset. Sorry,
So
long answer for a for a
now
long question.
it's okay, it's okay. So it means we need to also look up the data first and
Mhm.
like a cleansing, yeah.
Yeah,
So
data cleansing is important, and also, but also it's important to correlate with operational conditions if possible.
okay, pressure, temperature, etc. Yeah.
Yeah,
Okay,
yeah, speed of the gearbox, pressure of the pump, whatever.
okay, okay, okay.
Okay.
Guillermo. So some question maybe.
I mean, I'm sorry about this question about electromagnetic sensors. I don't know if this the person was able to answer, but I mean, I will do just if you do want, I will do just instead of an detailed answer, I will do just a general answer. So um, oil condition, for example, oil condition and wear processes are monitored by different technologies and they have their own benefits and disadvantages. I would say that for oil condition, using electrochemical properties or electromagnetic properties, it's the standard, but they have their own limitations because they are measuring polar, non-polar compounds. If you have water contamination, condition changes. If you have non-polar compounds such as diesel or another oil, the electrochemical changes in the other way. But we have also limitation in terms of water, in terms of air bubbles, and they also have limitation with bubbles. So I would say that there is not a technology that is worse or better in terms of oil condition because they are all affected by the environment. So it's important to filter out these interactions. And regarding wear processes, optical is different from other types of electromagnetic properties. We focus on lower detection limits. Okay, typically electromagnetic sensors for wear debris are above 50, 70 microns. We are measuring one order of magnitude less, that is 4 microns. So it's another approach. They are not measuring the same thing, I would say. They are full flow, we are in a bypass, so it's not the same technology. It doesn't make sense to compare because they are not doing the same in the same machine.
Ah, okay. Okay then. We already on the last question. Even though
Okay,
maybe some question still not answered yet, we can continue through personally, yeah, using the private email. So thank
okay.
you very much, Guillermo, for your very clear and explanation. Very insightful and practical, yeah.
Thank you very much, Adi, for moderating that, and I appreciate your effort into combining all the questions because there were a lot. Congratulations. There were a lot
Okay,
of
let
them.
me bahasa ya, iya, to continue ya. So Bapak
Mhm.
dan Ibu, terima kasih untuk Q&A-nya. Banyak sekali pertanyaan, tapi mohon maaf nggak semua bisa terjawab dan beberapa ada yang saya kumpulkan untuk dijawab dari Guillermo ya. Nah, selanjutnya terkait dengan webinar ini, eh, nanti akan dipilih ya dua penanya terbaik dan dua orang yang mengisi feedback survei. Kemudian juga nanti akan ditampilkan oleh tim terkait dengan upcoming webinar ya. Ya, jadi untuk saat ini kita akan pilih dua pertanyaan random apa terbaik ya, kurang lebih seperti itu untuk mendapat random ya, dua pertanyaan random untuk mendapatkan giveaway ya. Jadi yang untuk pertama peserta yang akan mendapatkan giveaway yaitu Bapak atau Ibu Bapak Bapak atau Bapak Srianto. Selamat kepada Bapak Srianto mendapatkan giveaway yang pertama. Selanjutnya eh attendance yang akan mendapatkan giveaway dari penanya-penanya yang ada di kolom Q&A yaitu Bapak di tengah-tengah biru. Oh iya. Bapak Kristanto. Selamat kepada Bapak Kristanto mendapatkan giveaway ya. Giveaway-nya apa nih ceritanya? Nanti akan dihubungi oleh panitia dari Mbak Tiara. Oke, selanjutnya yaitu terkait terkait webinar selanjutnya. Jadi webinar selanjutnya itu pada tanggal akan ditampilkan. Webinar selanjutnya tanggal 4 Maret itu jam berapa nih? Oh ini jam 1 siang ya. Jam 1 siang untuk industri mining terutama dari Atten 2. Jadi Bapak Ibu bisa scan barcode-nya untuk bisa registrasi. Kemudian webinar berikutnya pada tanggal 5 ya. Tanggal 5 Maret dari Tiara sendiri akan ada webinar terkait dengan benefit laser shaft alignment versus dial gauge. Nah, silakan Bapak Ibu untuk bisa register terkait webinar tanggal 3 dan 4 Maret di minggu depan ya. Untuk selanjutnya, form feedback untuk bisa diisikan nanti akan dipilih 2 orang partisipan juga untuk mendapatkan giveaway dan akan dihubungi oleh panitia ya. Untuk link sendiri akan ada di kolom chat, sudah ada ya. Nah, oke, kita udah ada di akhir session ya. Jadi terkait dengan Aten 2 ini ada sensor baik dari oil wear, oil health, oil master, SMK dan secara integrasi menggunakan software baik yang on-premise maupun cloud-based system ya. Jadi pada dasarnya nggak sekedar hanya memonitoring tetapi juga untuk mengetahui kondisi dari pelumas terutama sehingga ekspektasinya adalah kita bisa menjaga kehandalan dan meningkatkan efisiensi dari operasional. So, thank you very much, Guillermo, for your valuable presentation today. It's very insightful and practical. Terima kasih Bapak dan Ibu atas kehadirannya. Sampai bertemu di webinar berikutnya. Stay reliable and see you next time. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih semuanya.
Terima kasih semuanya.